Okay, we're going to find the limit at certain values on this graph. But before we do that, we want to first talk about what it means to find f of a certain value. For example, f of 0. F of 0 would be the y-coordinate for x-coordinate 0. So in this case, x would be 0 here, and the y-coordinate that goes with that is the y-coordinate 3. So f of 0 is 3. Notice this says f of x here, so the whole function is f. Similarly, if I were to ask, say, f of 2, f of 2 is right here. If you go up, it appears that f of 2 would be something just below 3. I'm going to say roughly 2.8. Now, this break over here, let's say f of negative 4, you'd think, well, there's two different values, but you're going to go with a shaded one. Okay, so f of negative 4 would equal negative 1. And at this value, where there's a hole and there's no shading at all, it's going to be undefined. There is no y-coordinate there. F of 4 would also be undefined because there is no y-coordinate there. Okay, so if you just see f of something, it is talking about a y-coordinate. Let's look at the limits. And we're going to start, we'll go back to f of 0. So what is the limit as x approaches 0 from the left of f of x? Okay, so this is asking for, here's 0, x is 0 here. As we approach from the left-hand side, what y-coordinate are you approaching as x approaches 0? Well, from the left-hand side, which, remember, this minus here means from the left. From the left-hand side, it looks like you're approaching the value 3. The limit as x approaches 0 from the right of f of x. Okay, so as you're approaching 0 from the right-hand side, you're also approaching 3. And this is common because nothing strange is going on here. This is what we call continuous function. It goes straight through there with nothing strange. Like we see this, what we call a jump discontinuity here, and a removable discontinuity here, and an infinite discontinuity there. Nothing like that's happening here. So it's very common for these limits to be the same from the left-hand side and from the right-hand side. Now the limit in general, which is in the big scheme of things, most limits we take are going to be the limit in general. The limit in general would be 3 as well. And that means, if you already have your left hand and your right hand, the limit in general, which would be a 0 with no sign, not a minus, which means from the left, or a plus, which means from the right, but just a plain old 0 with nothing, it would just be this equal value, the 2 3s. That just means from both sides it's approaching 3. In which, again, the big scheme of things, most of the limits we're going to take are going to be without a plus or minus here, because most limits are the same from left to right. Now, for these early examples, we'll have several limits that are not the same from left to right. So let's see what's happening from at negative 4, at 1, and at 4. So we'll start with negative 4. Okay, so we're going to do negative 4 from the left, negative 4 from the right, and negative 4 in general. Well, from the left, remember, this number is an x-coordinate. From the left, a limit always reports the y-coordinate at this x-coordinate. It would appear from the left that you're approaching y-coordinate 1. However, unlike the first example, from the right-hand side, negative 4 is here. From the right-hand side, you're approaching a different y-coordinate. Get to where you can see it there. From the right-hand side, you're approaching negative 1. And in general, since these do not match, we say that the general limit does not exist. DNE would be fine here. Okay, so from the left, it's negative 1 because that's the y. From the left, it's positive 1. That's the y-coordinate. From the right, it's negative 1. That's the y-coordinate again. But since these don't match, which is somewhat unusual in the big scheme of things, but not unusual in this first assignment, since it's not the same here, then we say it does not exist. All right, if I change these to 1s, there is something strange that goes on at 1, in that there's a hole, but from the left-hand side and from the right-hand side, it's going to the same place. It's going to the y-coordinate 4. Okay? The fact that the 4 is not actually there is not relevant. The limit is approaching 4. That means as I get closer and closer and closer to 1, x-coordinate, the y-coordinate is getting closer, closer, closer to 4. Because these match and agree, the in general limit is also 4. Again, this general limit just simply means the left hand and right hand agree, and then if they agree, you just take that same number. So even though there's this strange discontinuity, that does not affect the fact that we have a limit of 4. Finally, as we approach positive 4, from the left, positive 4 from the right, and positive 4 in general. Okay, this is what we call an infinite discontinuity, because it doesn't seem to be approaching a y-coordinate at all. It just seems to be going up forever. It's a vertical asymptote. Now, books, calculus courses, videos you may watch will differ here. Some courses, some videos will say the limit here does not exist either because it's not approaching an exact number. I like to say that the limit here is infinity because that is descriptive. That tells you what's happening there. And there are many videos that agree with me there. As you go up, as you approach 4 from the left-hand side, you are approaching infinity. From the right-hand side, same deal. Approaching infinity as you approach 4 from the right. And so our limit in general would be infinity as well. So basically you're looking for what happens from the left, what happens from the right, and you'll see if those two agree with each other.